The curious creatures of today's terrifically tantalizing video are alchemists extraordinaire. You'd call them Ed and Al because they're full metal alchemists. But who are these captivating creatures? Where were they found, and how are they able to excrete the stuff that powers our egocentric economy if it's toxic to them? Well, there's only one way to find out. We have two bacteria that use two different thrilling tactics. One is called D. acidovirans and the other Capividus metallidurans. Our first bacteria is Capividus metallidurans is a rod-shaped gram-negative metal-resistant bacteria. The bacterium within biofilms was first found in many tangible tiny deposits of gold in different regions on Australian metal mining mines. It was first thought that it just conspicuously contaminated metal. However, in 2009, metallidurans was first found to poop noteworthy golden newsworthy nuggets. Tiny ones, of course. If these bacteria were any bigger, biologists would give Mansa Musa a run for his money. Metallidurans means metal enduring. If you break it up, you can kind of see it. Metallidurans. So how do they make the gold if gold is toxic to most bacteria? Gold nanoparticles specifically, as they break down the bacteria's cell walls like a siege engine. Heavy metals in general are bad for bacteria, but these bacteria have evolved to survive in environments with these metals, which comes with perks like access to places other bacteria can't live in, less competition, which leads to greater rates of survival. And even if you do not pedantically pay precise attention in biology class, you know that survival is the name of the game released really though. Scientists, actually let's say microbiologists and bacteriologists, because this isn't a movie where one vague scientist knows everything, or are looking for something called unobtainium, which they can't obtain. Like, what is that name? Was this during a writer's strike or something? But anyway, scientists found out that if someone manages to ingest toxic gold compounds and convert them into the element's metallic form without any apparent danger to the organism itself. In simpler, a single distinct meaningful element of speech or writing used with others, or sometimes alone, form a sentence and typically shown with a space on either side when written or printed. The guy eats toxic gold compounds, sometimes liquids, and poops out solid pure gold. It lives in environments with heavy metals, in other words, they're like Megadeth. The heavy metals being mainly copper and gold, which can be highly harmful for the bacteria. It ingests the gold compounds, it uses the enzyme CUPA to convert the toxic compound back to normal gold. Or should I say, the pure element form. So it has to ingest the gold compound, but what if they could do it without ingesting the toxic gold first and also turn animal fat and lard into plastic? That is where the next bacteria comes in. D. acidovirans is a gram-negative rod-shaped saprophytic bacteria. It is saprophytic, feeding on already dead, probably drying, decaying matter, like tiny vultures. It also practices extracellular digestion, as in breaking down food extracellularly, like we do when we willingly chew. It is named Delphita after the place it was discovered, Delft in the Netherlands or Nederland, with acido meaning acid. This bacteria is different from metallidurans as it produces gold without ingesting it. It releases a certain protein, Delphitibactin A, as a defense mechanism. The protein acts as a shield for the bacteria and changes the poisonous ions into harmless particles that accumulate outside the cells. In simpler words, the guy spits out some chemicals to make its surrounding habitable, which also turns bad gold compounds into some of that green giving good gold. This is pretty cool as it can be used in salty sandy seawater where gold is in the form gold chloride. It can separate the gold from the chlorine like your parents' divorce. This is unquestionably useful, like putting these gold grabbing little guys down a stream or body of water to pre-check for gold presence before panicking and partaking in the panning of the stream sand to package and get paid for the precious prize. It also has other properties. With a little bioengineering, it can be used to manufacture polyhydroalkanoates from waste oils, which are polyesters, PHA bioplastics essentially, which are good as an alternative form to the way that we normally make plastics. They are biodegradable and don't melt at low temperatures as other bioplastics, but they are expensive, so we won't be seeing them being rolled out anytime soon. The world of microbes is clearly interesting with abilities we would consider superpowers, but it's something that you can do that they can't, so hit the subscribe button. Have a good day and stay hydrated, sub and stay off the hub.